So for this question we're asked to do two things. The first one is differentiate it. Second one is find where the tangent is horizontal. So differentiating this function, I will need to turn it into index form. Square root is to the power of a half. And then I can apply the chain rule. Derivative of the outside times the derivative of the inside. So what I've got here is 2x minus 2. That's this. All over 2 lots of. Negative means on the bottom of the fraction. The half means it's a square root. X squared minus 2x. And what I can see here is that I could factorise this top component as 2 lots of x minus 1. And then I'd be able to remove that 2. So by doing that I'm left with x minus 1 on the top and the square root of x squared minus 2x underneath. This is my gradient function. Now, for the second component, I need to find where the tangent is horizontal. Horizontal means flat, that is, I want y dash to be 0. Have a gradient of 0 will make it horizontal. So I do two things. I set y dash equal to 0, and then I solve. So my y dash is x minus 1, x squared minus 2x. I set that equal to 0, and now I solve. I see that means that x minus 1 must be equal to 0, x is equal to 1. That's because this is the only part of the equation that can make this equal 0. If the bottom bit equals 0, it would be undefined and not a solution. So I only look at the top component, I find where that equals 0. I do need to check. I just need to check. I have a little bit of a look here. Look into here and see. If I use this value, does it become undefined? If it does, then there is still no solution. So I look into here and I see that 1 minus 2 is not 0, so I'm safe. So this is the x coordinate where the tangent is horizontal. I do need to still find the y. I use the original function for that. So y equals the square root of x squared minus 2x. That's just from here, my original function. What I want to do now is find out the value for this when x equals 1. So evaluate that. This is another notation for evaluate the function y at the point 1. At the point 1, this becomes 1 squared minus 2 times 1, which is 2. Square root of 1 squared is 1 minus 2. So what I can see here is that I've got the square root of a negative number. What this means is that I can't actually take the square root of a negative number, so at this stage I would say that there is no point on my original curve. Let's just think about why this has occurred. This is the function. It tells us the gradient anywhere that we like. We didn't restrict the domain or the values that x could have in this function. However, in my original function, it's restricted. I can't have x's less than 0 here, nor can I have x's less than 2. That'll make this negative. That domain would flow into here. So even though this function did give us where the gradient would work there, that's just telling us algebraically there is a value that would make this function equal to 0. However, this actual place on the curve does not exist.